So in this lecture, what we're going to do is we're going to start going over exception handling, and this is the supplemental lecture to our exception handling lecture. And so the reason that I've created this little extra video is that a lot of students it doesn't quite sink in where you should be handling an exception and where you need to be raising an exception so that another method can handle it. So I'm going to walk through another application. We're going to do it together as if you're really coding one of your assignments, and hopefully the concepts will sink in as I start adding in the exception handling. So before we do that, let's go back to our application that was the example for our exception handling. And let's just take a look at what it did. So, we clicked this button, and this particular top level method, because no one else is going to call it, this button click event. So any method that no one else is going to call, such as anything that happens with a GUI, like a timer tick, a button click, a mouse hover, a key down event, any of these type of events are going to be top level methods. No one else is going to call them. And so whenever one of these methods occur, you want to actually handle the exception. And so all that means is the exception occurs and you present it to the user. You write it to disk, you write it to the database, something to that nature. You handle and you take action for the particular exception. And so notice when we click this button, we have a try-catch block and we call this method, which you'll notice method 1 then calls method 2. Now, method 1 is not a top-level method. You'll notice it's designed to be called by another method. So in its try-catch block, you can see that we're just throwing the exception here. Now, what we've done is that because I didn't want to hard code this sort of breadcrumb trail in this exception message here, what we did was we used something called reflection. And up here at the top, I had to include this namespace. And by using reflection, for instance, this method info class, there's a static method called getCurrentMethod. And so this returns you a handle to the current method that you're executing in. And then I say, hey, what's the declaring type that this method is in, which will return this class name here, form1. And oh, by the way, give me the name. So all of this line of code right here does is it returns form1. I then add on the string of what the method's name is itself. So it's going to say form1 dot method1, then tack on whatever exception got passed up to it. All I'm doing is creating my own breadcrumb trail. So is this required? No, but I think it's a really good way that if you want to find out, hey, this button got clicked, then it called this method, then it called this method, which then called a method in a different class, which then called it a method in a different class. It's a really helpful way that as a developer you can go into your database, you say, oh look, an exception got thrown, it's logged into the database, and you can see the whole entire trail of where that exception occurred. Is this the only way you can do it? Well, of course not. And when you're in the real world, you're going to have some sort of standards on how you should code and how you should handle exceptions, but this is just one way I've found to be useful. It's not necessarily the right way, it's just one way. So then method 1 calls method 2, where it's going to have a divide by 0 exception, and then you can notice that since method 2 is also meant to be called by other methods, we're just going to raise that exception up using the throw statement here. So I've also had generic exception handlers. So I want to make sure and make it clear that there's different ways, different perceptions on how you should always handle exceptions. In this class, I want it to be a learning experience. That's why I'm making you, after this lectured forward, or the exception handling lectured forward, they always have to have try-catch blocks in all of your method. Some people say you should never have a try-catch block unless you're handling very specific exceptions. Like if you knew there was a chance that you had a piece of code that could possibly have a divide by 0 exception, then rather than an exception here, you would actually put something like divide by 0 exception, where some people believe that it's bad practice to have generic exception handlers. You really should have specific ones. I'm not one of those people. I like to have generic exception handlers. I like to always be in control of what happens in my program. Again, I'm not saying it's right or wrong, but you're going to hear different ideas and depending on who you talk to. But in this class, I'm just doing it because I want you to have experience with using exception handling. So that's kind of what happens, and again, at the top level method here, it calls handle error, which again, all it does is go to a database, or in this case, gives it to the user, the information, and then writes it out to a file. So let's keep that in mind as we pretend we're writing, one of our assignments in the class. And so in this particular assignment, we've got a button on. Click on here. You know, it represents whichever assignment in the course you're trying to work on. So you click this button. The very first thing you should always do is comment the code and add a try-catch block. So all I have to do is type try tab tab, and it's going to put this code in here automatically for me. Then all I have to do is type ex, delete that out, and now I'm ready to add in my exception handling here and my code. So now you think to yourself, this is a top level method. Yes, it is. Okay, no one else is going to call this, so I know that I'm going to have to handle this exception. So why not just do the easiest thing possible? Go over to the code that I've already given you and just copy and paste this. So now you've got this method here that can handle the exception. And the next thing to do is just copy and paste the code that I've already given you right here into this method. So now you can write your code and you say, oh, look, there's an error. You click this, you click the little lightning bolt. Yes, what I really want to do is add system.reflection to the top, so it does that. And so now you've added exception handling for a button click. All right, fine. Well, let's say that we create a private void, test method. And so this is going to do something in our code here. So the next thing we need to do is we need to add exception handling. So we say try tab tab. We add an EX, we delete out this little throw here. Then we think to ourselves, this is a top level method or a method that's going to be called by another method. Well, it's not a top level method, it's designed to be called by another method. So in that case, all we're going to do is copy and paste this code into our own code, and you're done. And so what this is going to do now is, again, it's going to leave that little breadcrumb trail. And if you do this for every single method, as soon as you create it, as you're piecing your application together, these assignments together, you'll have the exception handling built in for when you add bugs into your program. It's going to happen, and your program's going to crash. But rather than just break on you, you'll get a nice, good error message that hopefully gives you some clue on how to fix the problem. Now let's say we right-click over here and we need to add in some business logic. So we never put that behind our UI. So we come over here to create our class and we say it's CLS, my class, whatever. And so we make our class public. And now let's say we add a public method, my test, public void, my test method. Now what's the very first thing we should do? Well, we should add a try-catch block. So we do tab tab, we add EX, and so now we have to ask ourselves, again, is this a top-level method or a method that's been designed to be called by another method? Well, any method that you ever add to one of these classes is always going to be designed to be called by another method. So the only possible answer here is to throw the exception. So we come back here, we just copy and paste that code in here, and we're done. And so again, we can come in here, click on our little light bulb, use system.reflection, and those will go away. Now it knows about this method info class. And so you would just do this for every one of the methods that you create inside a separate class, and that way any exceptions that your program throws will automatically get caught, and you'll know exactly where that exception gets thrown. So hopefully this kind of clears up some of the confusion you may have on when you handle the error and when you actually raise the error to the next level up. So again, just shoot me any emails if you have any questions. Thank you.